Gonna have to sync up. All right. 1, 2, 3. Go ahead, Jen. In 1 sec. When I clap. Gravity. It's something that binds us all to where we stand or sit or lay down right now. But what's the extreme? A black hole, the vacuum cleaner of space. Now, what is a black hole? It's dense, it's got pretty much infinite mass. Its gravity is so strong that light cannot escape from it. Now, it's got two parts. There's the singularity, which is the very middle of the black hole, is where the infinite mass is. That's where the strong gravity comes from. Then you have the event horizon. The event horizon differs depending on the black hole. If our sun were to become a black hole, if I can recall correctly, it'd be about 2.5 kilometers in diameter. Its event horizon, it would not be the same as the event horizon of the black hole in the center of our galaxy, Sagittarius A. The reason being, the Schwarzschild radius. That's what determines what the black hole, the event horizon is. So I was able to find a formula for it. The Schwarzschild radius is 2 times the gravitational constant times the mass of the black hole divided by the speed of light squared. So really, all of the radii of black holes and their event horizons are proportional to each other, depending on how much mass each black hole has. Now let's move on. Black holes are formed when supermassive blue stars reach the end of their lives. Now, these stars go out in a big supernova, sometimes hypernova, depending on the conditions that they blow up in. But the supernova will create either a neutron star or a black hole. Neutron stars are very unstable, and most of the time they tend to devolve into a black hole where they just collapse upon themselves. And that's what we see in black holes. We see the core of that star just collapse upon itself infinite times to one single point, which is the singularity. So that's why we believe that the singularity exists. Now, obviously, no one's been inside a black hole. No one wants to be inside of a black hole. So can we prove that a singularity exists? No, we can't. But given how mass cannot continue piling up, or else the event horizon would continue to expand outwards. That's why we have Hawking radiation, which is the decay of a black hole over time, where energy is lost and it shrinks and eventually will disappear. Black holes are dangerous for many reasons. You never want to go near them. I'm going to give you a couple reasons why. First off is spaghettification. Now, I'm sure a bunch of us has heard of this over the course of our childhood, but I'm going to come a little closer and I'm going to give us a demonstration on why spaghettification is bad. Now, here we have a 4-panel piece of paper. I'm going to draw an attractive middle-aged man. Let's call him Tim. Now, I cannot draw. Right? So, please don't take points off. We got Tim. There's Tim. Now, Tim decides that for whatever reason, he wants to jump off a diving board into a black hole. Now, Tim's not the very smart one of the group. But let's go with the hypothetical anyway. The line that I just drew is the event horizon, and Tim is going to pass it on his way towards the singularity. There's that. Now, as he travels downwards, the gravity at his feet will pull on him more than the gravity at the top of his head, thus elongating his body, probably causing massive amounts of pain. Not what you want to see. God, I am horrible drawing. You can see it there. And then Eventually, his body will reach a point where it is just two-dimensional and it's just you can't see it anymore when it reaches the singularity. Now, obviously, that's not a good way to go out. Could you press the screen? Thank you. So, time dilation and the theory of relativity all have something to do with this. E equals mc squared. The faster you go, the more time is going to change. Your time will be constant, but time for other people will appear to slow down or go faster depending on who is accelerating or not. I don't know if anybody here has seen the movie Interstellar. Fantastic movie. But in the movie, they are on a planet where the time is just so much faster than the rest of the universe because of their proximity to a black hole. They spend maybe a couple hours on the planet and a couple of years pass outside. So that's kind of like what you see in an actual black hole is if you got too close to it, time for everyone else would speed up to the point where you come away from the black hole and many years have passed. So, in summary, don't go near black holes. They're not worth it. Thank you.